Hi everyone, this is the video for chapter 2, lesson 5. So here we have the notes. Let's turn it off. Let's turn it. Can you take the bread out of the oven? Just stick it on there so I don't forget about it. This lesson is about absolute value. So let's give ourselves a little refresher of what that is. Absolute value of a number is its distance from 0 on a number line, and distance is always positive. So you're really just looking at how far away a number is from 0 is really what absolute value is. So -5 is 5 away from 0. +5 is 5 away from 0. So both -5 and +5 in absolute value is just 5. When evaluating expressions, absolute value bars act as grouping symbols. So let's write this down and then I'll explain that. What are grouping symbols in math? Well, that would be parentheses. So you kind of look at absolute values like a parentheses. You want to work out whatever is inside the absolute value and condense it down to one number before you interpret it as it's whatever its absolute value should be. So we'll do a few examples of that, but we can look at them and solve at kind of looking at them like they're parentheses. When solving equations with absolute value, there are two cases to consider. Case 1, the expression inside the absolute value symbol is positive. Case 2, the expression inside the absolute value is negative. So you really have to think through, okay, when you're working through these numbers, if our absolute value, what's inside the absolute value is a variable, we have to think through, okay, if A equals B, then A, the value of A could be either positive B or a negative B. And so A could be positive B and negative B, just as if I said, if the absolute value of X is 4, well, X, what goes inside this absolute value could be a +4 or it could be a -4. Because once I put that value inside the absolute value, remember, it changes it into a positive. So I could put either a negative or a positive of that same number, and the answer will always be the positive version, right? So it's important to check your answers when solving absolute value equations. There may be an extraneous solution. Can't say that word. Even when work is done correctly, the answer may not be an actual solution. Okay, so we'll take a look at that later. Because absolute value is always positive or 0, an equation like x equals -4 is never true because absolute value, just like we said right here, absolute value, it is the distance away from zero. You can't have a negative distance. A distance is always positive, like we mentioned above. So you can't have a solution where the answer to an absolute value problem would be a negative. And so if you have an answer that is a negative, that statement is just not true. So when it's never true, we say it has no solution. That's kind of the math way of saying this is not true. Solution. And it can be written as the empty set symbolized by brackets with nothing inside, or zero, empty set with a zero, kind of no solution sign. This is the no solution sign. Okay, let me fill this out. Written as the empty set. And it's symbolized by having, a set with nothing inside, so hence empty set, or a no solution symbol. So let's work out a few examples. First off, where we're solving, or another word, evaluating our answer by subbing in our values. And so this is where we kind of want to look at our absolute value as a grouping symbol. Probably shouldn't make it a parentheses all of a sudden, but I'm going to keep that absolute value. And then I'm going to rewrite my variable. H is 5, so I'm going to put H 5 in here in place of H. And then my plus 13 is outside. So I need to work out what's inside my absolute value. 3 minus 5 is negative 2. I'm going to keep that absolute value until I have kind of rewritten this as its true value. So the absolute value of 2 is positive 2. So now I'm going to write it as 2 plus 13, and that would be 15. Okay. I'm not doing anything to the 13. The 13 doesn't become either negative or positive because there's no absolute value around it. So I'm working out what's inside the absolute value, first condensing it down to one number, and then I'm going to interpret it as the value that it should be. Number 2, 16 minus negative 4 plus 9. So 16 minus, now I'm going to work this out, negative 4 plus 9 is positive 5. So I'm going to put this in absolute value positive 5. And absolute value of 5 is just 5. So nothing's changing here. But I'm just going to rewrite it anyway so that we can see we've now interpreted this absolute value as this number 5. And 16 minus 5 is 11. Okay, next one, F plus G. So F is 3, G is negative 4. So I'm going to rewrite, just bring everything down, put my plus sign, replace G with negative 4, minus H. I'm going to minus 5. I'm going to work out what's inside here. 3 plus negative 4 is negative 1. So I'm going to write this in absolute value first, minus 5, outside the absolute value, and then the absolute value of negative 1 is 1 minus 5. So 1 minus 5 is negative 4. And in this case, my answer is negative 4 because when I worked it out and then I subtracted 5 that was outside the absolute value, it was negative 4. Okay. Now we're going to solve an equation with absolute value. So the thing we have to consider is that whatever we simplify and work out, your answer, because it's saying the answer is 5, I could have x plus 7 in absolute value, giving me a positive 5 as a solution, or I can have x plus 7 in absolute value, giving me actually a negative 5 as a solution. But in the end, I'm not able to write my answer as a negative 5 because I know that whatever the absolute value of this value of that number is, it will be changed to become a positive. So I have to create 2 potential solutions, 2 cases for this equation. One case where my answer is a positive 5, one case where it is a -5. And I'm actually going to let me rewrite this so it's a little more clear. I'm actually going to take off the absolute value because it's where x plus 7 is 5 or x plus 7 is -5. So then it's just simple algebra. We're going to subtract 7 on both sides. X would be -2 here. And then over here, same thing. I'm going to subtract 7 on both sides. However, it's not -2 because -5 minus 7 is -12. So I actually have two solutions for this problem where x could be -2 or it could be -12. Either one of these solutions, if I plug it in place of x, will give me 5 as an answer once it's in absolute value. So let's just double check this. I'm not going to check every single problem, but I could put -2 plus 7, and I could put -12 plus 7. And when I work both of these out, -2 plus 7 is an absolute value of +5. -12 plus 7 is a negative absolute value of -5. Therefore, when I do actually write out my answer, absolute value of 5 is 5. Absolute value of -5 is also 5. So both of these solutions, if I put it in absolute value, are potential answers for x. Let's do another one. 3x minus 3 equals 9. So again, we've got to write out the two cases, the two potential solutions where I have a +9 as my answer, and I have a -9 as my answer. So I have to do two equations in order to solve for two potential numbers that x could be. So I'm going to add 3 on both sides. Um, 3x equals 12. Divide by 3 on both sides. X equals 4. Add 3 on both sides. 3x equals -6. Divide by 3 on both sides. X equals -2. So my two solutions would be either a -2 or a 4 as my potential answers for potential values for x. Let's look at number 6. Number 6, I want to highlight something. What do you notice about this answer? The answer is already telling you that it's going to be -6. That is not possible. You cannot have something worked out and simplified out in absolute value, and then all of a sudden the value of what's in the absolute value is a -6. This negative is unacceptable. So we are going to just immediately not even worry about solving all this, because the answer to this problem is that it is not a true equation. Absolute value cannot be negative. So you could explain like absolute value cannot be absolute value cannot be negative. And then how we would describe that is by using a symbol no solution. Okay, this means no solution. There's no possible answer for solving for n, because whatever you solve for n, your answer will not come out to be -6. All right, number 7, you've got your two cases. One case where 2t minus 4 is in fact 8, and one case where 2t minus 4 is -8. Working it out, +4 on both sides. I'm not doing really good showing all my work here because I want to keep this condensed. Divide by 2 on both sides, t equals 6. Again, plus 4 on both sides. This would be no plus 4 on both sides. -8 plus 4 is -4. Divide by 2 on both sides, t equals -2. So my solutions, I have a potential where t equals -2, or it could equal 6. And if I plug those back in to the original equation, I will see that either one of those could be the value of t. All right, we're going to write down a few instructions, and then I will explain, and I'm actually going to use this study guide, this old school version study guide, to explain this because there are already number lines drawn on here, and there are the problems with the points on the number line. And so it just is a little more simple for us to look at rather than having to plot our own points on a blank line. But I will fill out these instructions first. So what if you are trying to write an equation for an absolute value in a graph, okay? So let's write these instructions and then I'll explain it. You're gonna be like, what's going on here for a second, okay? Step 1, find the median between two graphed points. So if you have, let's say, 2, actually this would be -2 and 2. And these are your 2 points that are graphed. You are going to be looking for where is the middle, okay? One way to find the median is by just counting out that both points have to be equal distance from the middle, right? So -2 is 2 away from the middle here, 0, and +2 is 2 away from 0. So the median is at 0. Okay, step 2, find the distance from one point to the midpoint. So that's what I just did. I found the distance from one point to the midpoint. And I want to take this off. So I'm going to draw it like this. The distance is 2 here. And the distance on this side is also 2. So step 3, subtract the midpoint from the variable inside the absolute value symbols. Subtract the midpoint from the variable inside the absolute value symbols. So my midpoint here is 0. So if I were to create a absolute value, I'm going to subtract 0, and that's going to equal 2. And we're going to create our own equation. So we're going to put in a variable. Step 4, set the absolute value expression equal to the distance. So because I know that the distance on both sides is 2, that my absolute value is 2. Okay, so let's take a look at this study guide. We can look at these examples. The first example is actually solving the equation. So it's kind of backtracking a little bit. It is doing exactly what we just did on our first page of our notes, where we created 2 cases and solved, except for they also put a number line for you to check your answers. So I'm actually going to do 1 or 2 of these because it is going to help us use this information that we're seeing on this number line to create our own equations. So I'm going to do number 3 here because I've got some room I can do my work up here. So like I said, when we're solving equations, we're going to have two cases. We have a positive, and then we have the solution where it might be a negative. Then when we're working this out, we're going to subtract 3 on both sides, and this becomes -1. Subtract 3 on both sides, y equals -5. So your solution for this problem is that you have a -5 and a -1. So if I were to graph this, I would have -5 here and -1 here. Now I'm going to use kind of what we talked about on our creating our equations and just take a look at how this number line works out. My median is at -3. The distance between everything is 2. The distance between the points and the middle, the midpoint, is 2. Do you notice how in my equation, it was equal to 2? And then my median was the number that was put into my absolute value. So then the solutions are that y could be -1 plus 3, or y could be -5 plus 3. And the reason why it's +5 is because the original equation is y minus the value, the median value, which would be -3. And y minus -3 can be written as y plus 3, right? Subtracting a negative, you're going to add the opposite to simplify these double negatives, and that becomes adding 3. And so your equation is now y plus 3 and absolute value equals 2. I know it's a little bit messy. Let's go down to 13, 14, and 15, because now in these, the solutions are given to us. So this is kind of what we have to do. The solutions are given to us. We need to create the equations. I'm just dotting them big so we can see them really well. We need to create the equation. So what we're going to do is we are going to find the midpoint and then count out the distance from the midpoint to the solution set that they gave us. This is 2 away, and this is 2 away. Now, whatever I do in absolute value, it's going to equal 2 because the distance is 2. Then I'm going to identify my midpoint, my middle, and the middle is going to be the variable minus, so let's say y minus whatever that middle value is. Well, because it's y minus 0, I can just rewrite this as y equals, absolute value of y equals 2. Oh, I counted wrong. Do you notice that they were counting up by 2s? And so the distance is actually 4. So that makes all the difference. That's why it's not making sense, right? So let me erase all this stuff. Okay, so just be careful. I make this mistake too. I'm counting out 2 spaces, but because it's counting, the number line's counting up by 2, it's going 0 to 2, 2, 4, 6, 8. It's counting up by 2. So the distance actually is 4 here. And so it'd be y minus 4, or yeah, well, y minus 4 is equal to 4. Oh, no, y minus 0 is equal to 4 because the middle is 0. And so y minus 0 is still just y. So the absolute value of y is 4. Okay, these are counting up by 1, so hopefully that's a little bit better. My median is 1, and this time it is I am looking at the distance is 2, actually 2 this time. And so I'm going to write my equations as absolute value. I'm going to put it down here. Absolute value of something is going to equal 2 because the distance is 2. Then my median is 1. So I have x minus 1 as a potential set, or So my set is that I can have x minus 1 because my midpoint is 1. I'm going to do my variable minus whatever that midpoint is. Let's look at 15. So I think -3 is the midpoint. And these are counting up by 1, and that's 4 away. So my absolute value, whatever is in my equation, is going to equal to 4. And then I'm going to bring my midpoint down. That's -3. And I'm going to subtract it from my variable. So let's say this is s. S minus -3. I'm going to use a different variable. Because s looks like 5 sometimes. Let's say t, okay? T minus -3 in absolute value equals 4. Well, t minus -3 can also be written as t plus 3. And so when there's a double negative, rewrite it as adding the positive. Condense that double negative into one operation symbol. So your equation for this graph is that t plus 3 equals 4. All right, that's all I have today. I know these last 3 were probably a little more confusing. So the more you graph them on number lines, like if we were to actually do this problem and graph them, we would start to see how they're connected with what we're doing down here. So we'll probably do more of these graphing ones in class. If you're having trouble, let me know and I can maybe make an extra video to explain this a little more. That's all we have for today. Bye.